Hey everyone, so today's lesson is on section 13.2, which is called Indefinite Integrals. What this starts to bring in is just a little bit of the notation and how we can write the process of integration. Okay, we're still going to be doing exactly what we did in the previous one, which is increasing the power by 1 and dividing by the new power, increasing the power by 1, dividing by the new power, all of that stuff. Except now we just bring in how it's going to look when you see it in exams or in proper kind of mathematical contexts. So basically, this big kind of weird sort of stretched S means integrate whatever comes after it. So this means integrate this thing with an X in it, and then the dx that we put at the end, that means that it's the x's that we are integrating. Okay. So this means integrate anything in here with an x using the process increase the power by 1 divided by the new power. That's what that with that at the end of it means. For example, if I had something like this, integrate say x squared dx, that just means increase the power by 1 divided by the new power, so I'd get a third x cubed plus c. Okay. However, if I had say the integral of y squared dx, that wouldn't make any sense, because I haven't got any x's involved in this thing here to integrate. I've only got y's. So the fact that it's got a dx at the end there means that that thing can't work. We'll look more at stuff like that next year and how we sort of try and swap variables out so that we can integrate things. But that's effectively why there's a dx at the end there. It just means that you are going to integrate the things with the x's on. Okay. So let's have a little look then at some examples. What I'm going to do, there's quite a few examples on this, so I'm not going to do your turns and my turns. If you think you know what you're going to do on them, by all means just kind of rush ahead and see if you get it right. But basically, when you get something like this, do exactly the same thing as we did towards the end of the previous session, just integrate both of them separately. So increase the power by 1 divided by the new power. Well, a half increased by 1 will go to 3 over 2. Dividing by 3 over 2 will give me 2 over 3 x to the 3 over 2, and in this thing, increasing the power by 1 will go to 2x, sorry, we'll go to x to the 4, dividing that by the new power, 2 divided by 4 is half, x to the 4 plus c on that one. Okay, so can you do the next one? Pause the video, have a go at it. So this time, your power starts off at minus 3 over 2, so remember that's minus 1 and a half, so if I increase that by 1, I'll get to minus a half. So increase the power by 1 means we get x to the power of minus a half. Divide by the new power. Dividing by half is the same as doubling. So that'll end up being minus 2 x to the minus a half. And when we get a constant, a number like that, we just put an x on it. So that's my answer for part B there. If you managed to get that, well done. If you didn't, just sort of correct it now for us, please. Okay. Right, and then have a go at part C if you can. Okay. This one, it's nasty, this. So, if you've had a go at this, well done. If you haven't, if you just kind of said, imagine what we to say, that's absolutely fine. But it kind of brings in what we were talking about up here. I want to integrate here with respect to x. What that means is I can only integrate the x's. I can only increase the power divided by the increase the power by 1 divided by the new power for anything with an x. All of the things I have to just treat them as numbers. So this term here, I have to treat that p squared as if it is just a number. So it effectively just stays where it is. And then I just divide it by the new power that I'm going to get in a sec. So my x is going to go from minus 2 up to minus 1 in terms of its power. And then going to divide by that new power. Now that will just turn that p squared into minus p squared. And then this thing, well, what happened with 2 there? We just shoved an x on it, didn't we? So that's what we have to do with the q. That's what happens there. Notice it's only the x's that are changing in terms of integrating. You're only increasing the power by 1 divided by the new power on the thing with the x on. Everything else we treat as coefficients or just numbers. Right? Right, part D, 4t squared plus 6t. Does that mean I can't do that? No, it doesn't, because hopefully you've spotted that's got a dt at the end of it, hasn't it? Which means that t is now the letter that we can integrate with. Okay, so increase the power by 1 divided by the new power means that power is going up to 3, divide by your new power, and then that will just get a t on the end of it. Okay, this thing, pops up quite a lot. They like throwing in questions where they use a Q in there with the X's or something like that. So do make sure you sort of understand that one. Okay, we'll come up again on the next set of examples. Right, over the page, we'll have a look at example 5, and then you're going to do some questions. So this time we need to make sure that we can integrate. Now this basically is exactly the same thing as differentiating. You can only integrate if the thing isn't on the bottom of the fraction and it has a power. So at the minute, I need to rewrite all of these to be able to integrate them. So remember, anything that's on the bottom of a fraction, just put it on the top and the power changes to a negative. So this thing is going to become the integral of 2x to the minus 3, and then we rewrite roots as fractional powers, remember, so that'll be power over half. When it's like that, now I can integrate it, can't I? Increase the power by 1, so that'll go to x to the minus 2. Divide by the new power, 2 divided by minus 2 is minus 1, so that just becomes minus x to the minus 2. Increase your power by 1 goes to 3 over 2. Divide 3 by 3 over 2. Again, if you're unsure of this, 3 divided by 3 over 2. 2. So that will become minus 2x to the 3 over 2 plus c. Okay. Part B. What do we notice this time? We've got a bracket, haven't we? So let's expand the bracket and then let's see what we've got. I'm going to write this one a little bit further down. So it's going to give me the integral of x times x squared, gives me x cubed. That's absolutely fine. X times 2 over x means that x will cancel that x. So that's just plus 2. So now I can integrate it, increase the power by 1, divide by the new power. And the constant gets an x on the end. We're going to plus c. Okay. Now, this one, trickier again. So we're integrating this thing squared, which is 4x squared. Don't forget to square the 2 because it's inside the brackets. Right, this is hard, I think. So what we're going to do here is, you've got there, we're going to have root x over x squared, we'll simplify it in a sec, plus 5 over x squared dx. So splitting them up into single terms, and now we'll have to deal with the indices and everything. So we want the integral of 4x squared plus, that's x to the half, times, or over, say, x squared, plus, and again, the x squared in the bottom of the fraction there, that's going to be 5x to the minus 2. The reason I've left that one on there is because we can simplify it using indices. Now, when we're dividing things with powers, we just subtract the powers. So I'm going to do half, minus 2, that's going to give you minus 1.5, isn't it, which is minus 3 over 2. Now I can integrate it. Okay, so notice with something like this, we've gone through quite a lot of work there before we can even start to apply our increase the power by 1 divided by the new power. So on this one, increase the power by 1, it's going to go to x cubed, divide by the new power, so we're going to get 4 over 3 x cubed. This one, increase the power by 1, we're going to get to minus half. Divide by the new power, 1 divided by minus a half, do that in the calculator if you need to, is minus 2. So that's going to give us minus 2 x to the minus a half. And in this one, increase the power by 1, so we'll get x to the minus 1. Divide by the new power means this thing will just times 5 divided by minus 1 is minus 5. See? Okay, so that's your answer there. Right, what I'd like you to do, please, is have a go at the highlighted questions. Okay, so I've listed them out in the instructions as well, but it does go onto the next page there. Okay, I think I've set you 10 or 11 on there, so it is just practicing all of those. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. So you can probably do that one dead quickly, that one dead quickly, that one dead quickly, that one dead quickly. Remember there that r, when you integrate r with respect to x, you have to assume r is just a number that you don't know, constant, so that just becomes rx when you integrate it. These p's will just stay in there. Okay, that 2q, that'll just come to 2qx. Okay, those ones integrate it, it's got a dt there, hasn't it? So just integrate it with respect to t. This one, multiply this out and then integrate it. This one, make sure you write that as x to the minus a half plus 2x to the half, then integrate it. This one, multiply out the top, write that thing on the bottom as x to the half, and then simplify it all. Okay, and the ones over the page, again, question 10, rewrite it, 6x to the minus 2 plus 4x to the half, then you can integrate it. This one, p over 2, x to the minus, I have to write it out for you, p over 2, x to the minus 2 there, plus pq, okay, and then integrate all of that with respect to x. So remember there, increase the power by 1, divide by the new power, leave the p where it is. PQ integrated will become PQX, and then just have a little look at what you've got there and try and match it up to figure out what P and Q are. Okay. Any problems, let me know, and when you've finished, you can use the solution bank to mark your own work, but just upload photos to either Teams or Classrooms, please. That's all.